All right, so we have Chapter 9, problem number 35, another angular momentum problem. Ice skaters often end their performances with spin turns where they spin very fast about their center of mass with their arms folded in and legs together. Upon ending, their arms extend outward, proclaiming their finish. Not quite as noticeably, one leg goes out as well. Suppose that the moment of inertia of a skater with arms out and one leg extended is 3.2 kilogram meters squared, and for arms and legs in is 0.8 kilogram meters squared. If she starts out spinning at 5 revolutions per second, what is her angular speed in revolutions per second when her arms and one leg open outward? So I need to make one quick little change. I made a mistake in the unit, so let me just do that. Excellent. So now, if we look at the problem and we start to figure out what we want, we should remember from working all kinds of other momentum problems, linear momentum problems, and not just angular momentum, but all momentum, that momentum is always conserved as long as there's no outside torque or an outside force causing a change in momentum. So because of that, we can say that the starting angular momentum has to equal the final angular momentum. Okay? Going from there, moving forward, angular momentum we know is moment of inertia times omega, and that's going to be the initial items. That has to equal the final moment of inertia and final angular speed. So plugging in for what we've got here, we know that when all 2 of our arms and 1 of the legs is extended, right, we've got a moment of inertia of 3.2 kilogram meters squared, and they're spinning at 5 revolutions per second. And when they pull those arms and leg in, or leave the leg out, so pull the arms in, the moment of inertia goes down, which, if you remember what we've talked about in class, makes sense because the moment of inertia needs to go down because now we have less mass extended out from our axle, from our position of rotation, right? So when the moment of inertia goes down, what has to happen is this speed, this angular speed, needs to increase so that we keep momentum conserved. So if we solve for omega sub f, we find out that by pulling those arms in, making the moment of inertia go down, that now this skater is going to rotate at 20 revolutions per second. So there you go. That was problem number 35 from Chapter 9.